Hi class, I've created this video on solving for the dependent variable in trigonometric functions. I've just made some extra examples because over the years I've seen that students have difficulty with this concept. So I just wanted to go over the best methods there are to solving these types of problems. So the first thing I like to do is just draw a pretty quick sketch of what the situation is, just so I can get an idea of how many solutions I should be getting. So I can take a look at this, and again, it's just a really basic sketch. So my max is going to be 4 plus 3.2, which is 7.2, and my min is going to be 4 minus 3.2, so 0.8. So my whole function is going to be occurring above the x-axis. I also know that I need data up to 8, all right? My period is 2 pi divided by k. So in this case, 2 pi divided by 2 pi over 5, which is the same thing as 2 pi times 5 over 2 pi. So I just get 5 after these guys cross out. So I'm just going to go up by ones. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to make an approximate axis here at 4. Okay, and I notice that my phase shift is 1 to the right, so I'm going to start here at 1 on my axis. And I know that an entire period is 5, so again, 1 plus 5 is 6, so at 6 it'll be on the axis again. And then halfway in between, so at 3.5, it'll also be on the axis. Okay, half of 2.5 is 1.25, so I will have my maximum occurring about here and my minimum occurring about here. And then another maximum happening at about here, and then some other stuff going on. Okay, so I'm not sure exactly where this ends up, but it's going to go somewhere like that, and then up, down, up, and then I'm not sure where exactly it ends at 8. Okay, I know at 8.5, it's again back on the axis, but I don't know exactly where it goes there. Okay, so the question is asking, where is this function hitting 2? So 2 is, oh, I didn't even make it go down enough. So 2 is somewhere in here. I should have made that here, just to make it a bit more accurate. I'm going to make that minimum more of where it should be. Okay, it's okay to make adjustments, right? So it's closer to the x-axis. It's much further down there. Okay, so I want to know when my curve is hitting 2. So 2 is about here. It's halfway between 0 and the axis. So I know I'm going to be hitting it at 2 points here and here. But do I hit it over here? I'm not sure because I didn't actually do the work. So I'm going to have at least 2 solutions to this, perhaps 3. So now I need to get into the actual algebra and start solving this. So I set my 3.2 sine 2 pi over 5 t minus 1 plus 4 equal to 2. Okay, and now I need to start solving this. So I can move the 4 and the 3.2 over. So I get sine bracket 2 pi over 5 t minus 1 equals negative 0.625 when I subtract 4 and divide by 3.2. So now I have to let this guy in the middle here be the argument. I can't actually divide that out or do anything fun with that. I have to say let u be equal to 2 pi over 5 bracket t minus 1. Okay, and now I'm going to be solving sine u equals minus 0.625. So I'm going to solve for u, get my answers for u, and then convert them back into forms of t by setting them equal to this. Okay, but for now I'm just looking at sine u. So when I look at the Cartesian plane, there's 2 quadrants in which sine can be negative. So I could terminate in this quadrant or in this quadrant. So I can label, I have 2 options here, my u1 and my u2. Okay, so what do they share in common? Well, they're both going to have the same related acute angle. So there's beta for u1 and there's beta for u2. So now I'm going to go ahead and find beta. Okay, beta is just, you can use your calculator. We undo sine of 0.625. Remember, I don't use the negative version because I want the angle to be acute. So my calculator does its thing, and it lets me know that beta is 0.6751 when you round. So that's the related acute angle that has this sine value. So then I use my Cartesian plane to say, okay, U1 is just pi plus beta. So I use the pi button in my calculator, I add beta, and I get 3.8167. And U2 is 2 pi minus beta, because it's here, right? So U2 is just 2 pi minus my beta, and that gives me a value of 5.6081. Okay, so those are my two values for U. Now I need to convert them back into time. So I set them back equal to 2 pi t minus 1. So 3.8167 equals 2 pi over 5 bracket t minus 1. So I multiply both sides by 5 and then divide by 2 pi, and then I add 1. Okay, so I'm just going back and isolating t. So again, I multiply by 5, divide by 2 pi, add 1, and t1 is equal to 4.03. Now, if I go back to my sine curve up here, that makes sense. There it is. That's the one, 4.03. That looks right. It's just above 4. Okay, so now I take this guy and I set it equal back to U again. So 5.6081 equals 2 pi over 5 bracket t minus 1. So again, I multiply by 5, divide by 2 pi, and add 1, and I get t2 is equal to 0.4628. Okay, so that means that there is a time that happens within 0 to 8. So that means that this does exist. That's that one. So now I got to think, how do I come up with this answer then? So I was given this answer and this answer. How do I come up with this answer? Well, you just have to add one period. So another period you just add, which is 5. So you add t2 plus 5. So you get 5.4628, which if you look at this, that matches up to where it should be. So there you go. Those are your three solutions, 4.03, 0.4628, and 5.4628. Those are all of the t values that make this function equal to 2 between t values of 0 to 8. Okay, so now we can do example 2. Notice here it's an inequality, so you definitely need your graph to help inform your decision here. All right, so notice this is a coast curve, and my maximum is going to be 16, and my minimum is going to be 4. So this is all also above the x-axis, so I can just draw it like this. So my max, I use that because my max is 16 and my min is 4. My axis is at 10. Okay, I also want to show back minus 1 because notice this is going left 1, so I'm going to extend it back to negative 1. And I only care between 0 and 3. My period is 2 pi divided by k, which is the same as 2 pi times 2 over 3 pi. So I get that it's just equal to 4/3. Okay, so my period is 4/3, which is 1 1/3. So if I move this back as minus 1, here's 1, 2, 3. This is going to be just super estimated. You'll see it's not going to be anything special. Okay, so this is 16 as my max, and we'll say this is 4 as my min. And so now I'm going to go to town and have fun with this. So my maximum starts, because it's all being shifted over, at 1. So I have a maximum here. And then my period is 1 1/3. So I'm going to have another maximum at 1/3, which is here. Okay, so then I'm going to have another maximum 1 1/3 from there. So 1 1/3-ish. And then over here, I'm going to have another one. Okay, so then my minimums are halfway in between. Okay, and then I can kind of just have fun with graphing this. So it comes up like this. And then 12 is approximately here. So it looks like I might have an answer here. I get an answer here, an answer here, an answer here, and an answer here, because this is about where 12 is. So I for sure have 1, 2, 3, 4, possibly 5 solutions here. So basically, I just need to solve for when h of t is equal to 12, and then use my graph to say when it's above 12, okay? So I set my function equal to 12. So 6 cos 3 pi over 2 t plus 1 plus 10 equals 12. Okay, so I then move over 10 and divide by 6. So I get cos of 3 pi over 2 t plus 1 equals 1/3 when I put it in lowest terms. Okay, so now I do my thing where I say let u be equal to the argument, so 3 pi over 2 t plus 1. Okay, and now I'm just solving for cos u equals 1/3. Okay, so this is, it looks like it might be from a special triangle, but it's not, okay? So if this was a ratio from a special triangle, I could come up with exact values, but it's not. It would be 1 over root 3 might be, but 1 over 3 is not. So cos is positive in 2 quadrants, quadrant 1 and quadrant 4. So I have u1 being here and u2 happening over here. Okay, so now I have to actually solve for beta. They have the same beta. So beta is just, use your calculator, the inverse cos of 1/3. So make sure you're using the fraction. And you'll find, if your calculator is in radians, that beta is equal to 1.23. Okay, so u1 is just the same as beta. So it is 1.23. And u2 is just 2 pi minus beta, and that is equal to 5.05. So now we convert these into time. So I'd invite you to set these equal to what this is and solve for it. What you should find is that t1 equals negative 0.739 and t2 equals 0.0723. Now, this guy is not admissible because he's not between 0 and 3. Because this is actually the guy that would have occurred here, okay? So this one actually doesn't exist. It would have been over here, so we don't actually include him in our solution, but we can use him to find other guys. So now what we would do is we just keep adding periods to find the next one. So to find the next one, T3, we just take T1 and add a period, which in this case is 4/3. Okay, so that one we get 1.4056, and we can find another one by adding another period, and that gives us 2.7389. So there we go. So we can label these up here, the 1.405, oops. The 1.405 is here, okay, and 2.3. Okay, So there we go. And with this one, again, we can just keep adding periods. So we take this 0.0723 and add a period onto it. So that gives us 1.9276. Okay, and I'm just trying to figure out where this 0.5943 comes from. Okay, and then another one is 0.5943. Okay, I think that's actually from this addition over here. I think I might have switched these up. Okay, so basically you just take your first two t values though, and you just keep adding 4/3 to each of them until you get past 3. Once you get any numbers that are past 3, they're not included. So you can see I am above 12 between this first value and this second value when they go in order. So my first solution here then would be between that first value, which is 0.07. See, that's the smallest value. And the next smallest value, oops, don't do the inclusion. The next smallest value, which is the 0.59. There it is. Okay, and then if you go to the next, it's between the next two. So the next highest one and the next highest one. So then that would be the 1.4, this one, and the next highest with it is the 1.9. Why do I keep doing that? No inclusions there. Okay. And then you can see that it's also above from this point until where it ends at 3. So that point is this 2.74 approximately. And now I'm going to include 3. So I did actually mean to put the inclusion on that last one, because at exactly 3, it is still greater than 12. And notice that the question asked for when t is between 0 and 3, where 0 and 3 are included. So that's how you do that one. You actually solve for 12 and then use your sketch to say to see where it is above 12. Okay, guys? So thanks for watching. Hope you learned.